Hi guys, let's understand the problem 2997. Minimum number of operation to make array XOR equals to k. Okay, so what this question says, let's understand the problem. Okay, suppose, what is this? Suppose I have an array with A, B, C, D. Okay, now I can do is suppose if my A looks like 1, 1, 0, 1. Okay, so if I XOR all these A, B, C, and D, then the resultant should be equals to K. Suppose if I have 1, 0, okay, and my K is 1. So if I XOR 1 and 0, it would be resultant to 1. And is this equals to K? Yes. So I will say I need 0 operations to convert this array XOR equals to K. Now suppose, what if my the array look like 1, 2, 1, 2, and the k is 1. Okay. Now, if I XOR all of this, it will result in me 0 because 1, 1 will cancel, and 0, 0, 2, 2 will cancel, and the resultant would be 0. And this is not equals to k. So I have to tell the minimum number of bits I have to change in this array so that suppose this would look like this would look like this would look like this, and this would look like this. I have to tell me how many bits do I have to change, the minimum number of bits, so that the XOR of all of this give me 1. Okay. So what can I think of? What is the property of XOR? Understand this. Suppose if I have 1 and 1, if I XOR this, it will result in me 0. 1 and 0, 1. 0 or 1, 1. 0, 0, 0. Okay? Just keep this in mind whenever you are solving the XOR. Okay? This is the main important thing. Okay? Now, 1, 1 will give me 0. 1, 0 give me 1. 0, 1 will 1. 0, 0 will 0. Means similar give dissimilar, dissimilar gives a setback. Okay, so what can I think of? I don't like I keep on changing each bit of each number and then I keep on XORing and then checking the case is equals to k or not. This is not a good approach. Okay, it will give me a really high complexity and it is not this. Now suppose I take an example of 1, 1, 2, and let's take 3 and 4. Order doesn't matter. Okay. And my k is it 1 here? So what is the bit of 1? It is 0, 0, 1. 2, 0, 1, 0. What is 3? 0, 1, 1. And what is 4? It will give me 1, 0, 0. Okay. Now if I XOR all of this, it will give me 1, 1 would give me, so 1, 1, 1, 0, 1, 0. It will give me 0. 0, 1, 1, 0, 0. It will give me 1. But this is giving me 4. But I need 1. So what can I think of is, take this, like separate this. Now what if I change this 1 to 0, it will give me 1. Okay. Now if I keep this as it is, and if I change, suppose this as 1, it will give me 0. Okay. If I change this to 1 or this to 1, okay, or this to 1, or this 1 to 0. This will always give me a 0. Okay, means I don't have to keep on checking which bit I have to change. I can change any bit. I can set, I can change 1 to 0 or 0 to 1 to change the resultant value. Suppose if I have something like 1010 dot n, any any substance, anything like 10, and in the end, if I XOR this, it will give me the 1. Now, if I change any bit, either 1 to 0 or 0 to 1, this will this will flip my bit. If I flip this bit to 0, this will give me 0. Okay. Or if I flip this 1, 0 to 1, it will give me 0. So I don't have to care which bit I have to change. I can simply just convert one bit of this sequence, any bit, to flip my answer. Okay, understood? So now let's take the concept. Let's take the concept. The answer was 110, and I need 001. Okay, so to flip this 0 to 1, I can change any bit. I can change any bit of this sequence. So I just give +1 and this will become 1. Since this is equal, I want here, I move forward. And if this is 1, I can just simply turn any bit, flip any bit, and it will give me 0. So I get the same value. And total value is only 2 steps. Okay, so let's code this out. Okay, so I have to find the XOR of all the, I will say all XOR equals to 0 for I in num. What I will do is all XOR equals to XOR. Right. Okay. In this, what I did was uh, finding of XOR of numbers. Okay. Now I have to find the minimum number of steps. So I will return breadth, which will be my this would be my number of bits I have to change in numbers. Okay. Now how? Now I have to compare. Now what I have to do is compare A with all XOR. Okay. So what I can do is uh, in integer there are only 32 bits. So I will keep right shifting. Suppose I will keep checking this area and I'll left shift this. Then I move this forward. I move this forward. Let me finish it. I execute my iterator with 32. In integer there are 32 bits. So while I and in the end I will just move left step. But in this I'm doing comparison. Comparison A with XOR in which how many bits are different. Okay, how many bits are different? So what I will do is find the most significant bit of all XOR. I will say X would be all XOR and what? Okay, in this by this, suppose I have a value like 0, 0, 1. And if I end with 1, it will give me the most significant bit. Okay. And same with k, 10 k equal to k 1. Okay. Now, if 10x not equal to 10k, I'll just simply increase the bit. And what I will do is 10x left shift one time and say 10, no, or dot and k. Okay. This is my board, and now it should end properly. Listen this. This I'm finding all XOR and comparing the k with all XOR, how many bits are different, and returning the number of different bits. And let's submit this. It's a simple math problem with the XOR. So let's submit this is submit. Yeah, it's been accepted. Hope you understand the concept of XOR and the array. Okay. If you understand, just give it a like. Okay. See ya.